From the Cold War to the hypersonic future, this is the story of how we've owned the skies. In 1966, as the Vietnam War intensified, an aircraft unlike any other entered service. The SR-71 Blackbird, a machine that even today, nearly 6 decades later, holds speed and altitude records no other air-breathing, piloted aircraft has broken. As General Curtis LeMay, then Air Force Chief of Staff, remarked upon first seeing the aircraft, "That looks like a plane I want in my Air Force." 2,193 miles per hour. Mach 3.32. So fast that the air itself became a blowtorch, heating the Blackbird's skin beyond 500 degrees Fahrenheit. So high at 85,069 feet that pilots needed pressurized spacesuits similar to astronauts. The aircraft actually grew several inches in flight due to thermal expansion. But the Blackbird was more than just numbers. It was the embodiment of American engineering audacity. Kelly Johnson, the legendary head of Lockheed's Skunk Works, who spearheaded the SR-71's development, had a simple philosophy: be quick, be quiet, or be gone. The Blackbird embraced all three. Johnson famously demanded, "I don't want to hear about what you can't do. Tell me what you can do." His team delivered an aircraft 30 years ahead of its time. When Soviet SA-2 missiles locked onto a Blackbird, the response wasn't countermeasures or evasive maneuvers. It was simply to accelerate. Colonel Jim Wadkins, an SR-71 pilot, explained it perfectly. It was not uncommon to see a missile launch, but we were flying so high and so fast that the SAMs couldn't reach us. In addition, we were stealthy enough that if they did launch, we could outrun them easily. Despite more than 4,000 SAMs launched against Blackbirds during their operational history, not a single one was ever hit by enemy fire. When Syrian missiles targeted an SR-71 during a 1982 Beirut overflight, the crew simply pushed the throttles forward and outran 6 incoming surface-to-air missiles. Major Brian Schul, an SR-71 pilot, once quipped, "We weren't evading the missiles. We were simply moving ahead to a different part of the sky than where the missiles were going." This wasn't just an airplane. It was American technological dominance cast in titanium. 93% titanium, to be exact, sourced covertly from the Soviet Union itself through shell companies. Cold War irony at its finest. The metal was so difficult to work with that Lockheed had to develop entirely new tools and manufacturing processes just to build the aircraft. But the Blackbird's capabilities came at extraordinary cost. Each mission required 450 personnel for pre-flight preparations, specialized JP-7 fuel that leaked from the airframe until heat expansion sealed the joints, weekly engine rebuilds due to extreme thermal stress, and $18,000 per hour in operating costs, in 1990 dollars. The Pratt & Whitney J58 engines powering the SR-71 were marvels of engineering, hybrid propulsion systems that began as turbojets but functioned more like ramjets at high speeds. At Mach 3.2, more than half of the thrust came not from the engine core, but from the inlet compression system itself. So what changed? Why did we retire the fastest plane ever built? The simple answer: satellites and drones. The complex answer lies in how warfare and intelligence gathering evolved. As General Michael E. Ryan, former Air Force Chief of Staff, explained during the final retirement ceremony in 1999, the Blackbird's time has come and gone. But what it stood for, American ingenuity, technological superiority, and the quest to push boundaries, those values continue in systems invisible to the public eye. Today's reconnaissance platforms prioritize stealth and persistence over raw speed. Consider the RQ-180, so stealthy its radar cross-section is less than 1,000th that of the SR-71. While the Blackbird could be detected, but not caught, today's stealth drones simply aren't seen at all. As Lieutenant General David Deptula, former USAF Deputy Chief of Staff for Intelligence, put it, 21st century warfare requires persistent ISR with minimal signature. Speed matters less than staying power. The MQ-9 Reaper can loiter for 30 hours, more than 10 times longer than the SR-71's typical mission. And unlike the Blackbird, which required landing to deliver its film canisters for processing, modern platforms transmit data in real time through encrypted satellite links. They can also deliver precision strikes themselves, something the Blackbird was never designed to do. The venerable U-2 Dragon Lady, the Blackbird's predecessor, has outlived its faster descendant through constant modernization. Today's U-2S integrates quantum computing elements and open mission systems architecture that processes intelligence 1,000 times faster than systems from the 1990s. Colonel Dustin Brown, commander of the 9th Reconnaissance Wing, noted in 2020, "The U-2 proves that longevity in platforms comes from adaptability. What began as a camera platform now serves as an airborne supercomputer. But there's something about speed that still matters. Something about the ability to get somewhere fast when you need to. What military planners call responsive ISR. This is where the Blackbird still reigns supreme. When a crisis erupts, satellites may be out of position. Drones may take hours to arrive. But the SR-71 could dash from one side of the ocean to the other in under 2 hours. New York to London in 1 hour, 54 minutes. A record set in 1974 that still stands. The aircraft's refueling procedures alone were a marvel of precision, with tanker aircraft struggling to fly fast enough for the Blackbird to refuel at its minimum sustainable airspeed. Admiral Harry Harris, former commander of U.S. Pacific Command, stated in 2017, "In contested environments, speed becomes a critical factor again. The ability to penetrate defended airspace quickly may be the difference between having intelligence and having none." Perhaps that's why Lockheed Martin isn't just resting on the Blackbird's legacy. They're building its successor, the SR-72 Darkstar. As Rob Weiss, former executive vice president of Lockheed's Advanced Development Programs, revealed, "Hypersonic is the new stealth. What was once about hiding is now about simply outrunning the threat." The SR-72 aims to double the Blackbird's already staggering speed, reaching Mach 6, over 4,500 miles per hour. At those velocities, the aircraft doesn't just outrun missiles, it outruns the radio waves controlling them. The heat generated at such speeds would melt conventional materials like butter. Powered by a revolutionary propulsion system that combines turbine and scramjet engines, the Darkstar will transition seamlessly from takeoff to hypersonic flight. Its skin, subjected to temperatures exceeding 3,500 degrees Fahrenheit, will utilize ceramic matrix composites instead of titanium. Special cooling systems will manage heat loads that would vaporize the SR-71. Brad Leland, Lockheed Martin's Hypersonics program manager, stated, "Hypersonic aircraft, coupled with hypersonic missiles, could penetrate denied airspace and strike at nearly any location across a continent in less than an hour." This isn't science fiction, it's engineering reality in progress. Unlike its predecessor, the SR-72 will likely operate autonomously, AI replacing the human pilot and reconnaissance officer who once endured the physical extremes of high-speed, high-altitude flight. The G-forces and heat generated at Mach 6 would simply be too much for human physiology. And unlike the purely reconnaissance-focused SR-71, the Darkstar will have strike capabilities. At Mach 6, a hypersonic missile doesn't just destroy targets. It reaches them before decisions can be made to move them. Former Secretary of the Air Force Heather Wilson noted, "Hypersonic weapons and aircraft are a game changer, not an evolution. They fundamentally alter response times in the calculus of strategic warning. But technical specifications alone don't capture what made the Blackbird special or what will define its successor." The SR-71 represented more than military capability. It showed what humans could achieve when pushed to solve impossible problems. Ben Rich, who succeeded Kelly Johnson at Skunk Works, once said, "We have built planes that are unintentionally stealthy, but the Blackbird was intentionally fast." He later reflected, "Everything had to be invented. Everything." The SR-71 was built with slide rules, not supercomputers. Designed with paper drafting tools, not CAD software. Its creation required metallurgists to develop new titanium alloys and manufacturing techniques on the fly. The fuel tanks leaked on the ground by design. Only heating and expansion at speed sealed them properly. Major General Eldon Jors, who piloted the Blackbird's record-setting speed run, remarked, "Flying the SR-71 was like strapping yourself to a rocket, not just because of the acceleration, but because you knew you were riding something extraordinary, a piece of history with every flight." Today's engineers stand on those giants' shoulders. The thermal barrier that the Blackbird first penetrated, speeds where friction heats airframes beyond conventional materials limits, is the same barrier the SR-72 must transcend to reach Mach 6. Dr. Mark Lewis, former Air Force chief scientist, observed, "The principles of hypersonic flight were understood in the 1960s. What we lacked then were the materials, computing power, and manufacturing techniques to fully exploit them. Now we have all three. If there's a lesson in the Blackbird's legacy, it's that American aerospace supremacy has never come from incrementalism. The leap from propeller aircraft to jets to supersonic flight to hypersonic dominance has always required bold thinking and calculated risk." The SR-71 wasn't just fast, it was transformative, changing how we thought about the possible. Its records have stood not because we can't break them, but because for decades we haven't needed to. As Brigadier General Kevin Chilton, former astronaut and strategic command leader, put it, "The Blackbird represents what happens when we remove arbitrary constraints and simply ask, how fast can we go?" Now, as new global competitors emerge and space becomes increasingly contested, the need for speed returns. The ability to traverse vast distances quickly, observe, and if necessary, act, remains a cornerstone of strategic advantage. General John Hyten, former vice chairman of the Joint Chiefs of Staff, warned in 2018, "Our adversaries are moving at incredible speeds in developing hypersonic technology. We cannot afford to cede this domain." So while stealth drones silently patrol our world's troubled regions and satellites maintain their silent vigil from orbit, the spirit of the Blackbird lives on, in museums where visitors still marvel at its sleek, sinister silhouette, and in the cutting-edge laboratories where the hypersonic future takes shape. Colonel Richard Graham, former SR-71 squadron commander, reflected, "In the SR-71, we routinely flew more than twice as fast as a rifle bullet, and at altitudes that would kill an unprotected human in seconds. Every mission was a testament to what American engineering could achieve. We may never see another aircraft quite like the SR-71 Blackbird, but its legacy of pushing boundaries, of turning the impossible into reality, continues to inspire each generation of aerospace pioneers." In the words of Major Brian Schul, SR-71 pilot and renowned Blackbird chronicler, "You don't ride in the Blackbird, you wear it. And it takes you places humans weren't meant to go. The jet becomes an extension of yourself, responding to your slightest inputs as you hurtle across continents faster than anyone in history. The question isn't whether we'll return to those extreme heights and speeds. The question is how far beyond them we'll go. From the Blackbird to the Dark Star, the shadows above us are cast by American ingenuity, keeping watch, standing guard, and when needed, arriving with unmatched speed and purpose. This is the legacy of the SR-71, and it's still unfolding before our eyes."